Hello, I'm Ryan Young. Today we're doing Module 26206, Conductor Installations. Let's get started. Module 26206, Conductor Installation. A successful completion of the module prepares you to do the following: explain how to install cable and conduit systems, explain how to set up for high force cable pulling, and identify cable limitations when pulling. In most cases, the installation of conductors and raceway systems is merely routine. However, there are certain practices that can reduce labor and materials and help prevent damage to the conductors. This module describes how to prepare a conduit for conductors. It also explains how to set up and complete a cable pulling installation. 1.0.0 Installing cable and conduit systems. Explain how to install cable and conduit systems, identify how to plan the installation, identify a pulling location and set up the cable reels, describe how to prepare raceways for conductors, explain how to install a pull line, describe how to prepare the cable ends for pulling, describe how to select cable pulling equipment. After the conduit system's been installed, the next step is to pull the conductors. The simplest method of cable installation involves running stiff but flexible fish tapes through the conduit run and using it to pull the conductors. There are three types of fish tapes: steel, nylon, and fiberglass. They also come in different weights for various applications. Proper size and length of the fish tape, as well as the material, should be one of the first considerations. For example, if most of the runs between branch circuit outlets are short, a shorter fish tape can be used and will be easier to handle than a larger tape. When longer runs are encountered, the required length of the fish tape should be enclosed in one of the metal or plastic fish tape reels. This way, the fish tape can be rewound on the reel as the pull is being made to avoid having an excessive length of tape lying around on the floor. Never pull conductive fish tape through or into an enclosure or raceway containing an energized conductor. Metal fish tapes can have sharp edges and burrs. To avoid injury, wear heavy-duty gloves when working with them. So we have a basket grip. The basket grip is available in many sizes for almost any size and combination of conductors. It's designed to hold the conductors firmly without taping them to the pulling line. And all but the shortest runs, the wires should be lubricated with wire lubricant before attempting the pull, as well as during the pull. Some lubricant should also be applied to the inside of the conduit. Always follow the wire manufacturer's recommendations when electing lubricants. Many types of cable now have no lube insulation, which is a very slick surface that does not require lubrication. So wire dispensers, they're great aids in keeping the conductors straight and facilitating the pull. Many different types of wire dispensers are available to handle virtually any size of spool of wire cable. So here's a wire reel cart. Here's a wire reel dispenser. When fishing conductors in a conduit or raceway that already contains energized conductors, the safest method is to turn off, lock out, and tag the power source for all the live conductors. However, in some rare instances, fishing a conductor through a conduit or raceway containing other live conductors may be unavoidable. In this case, always request your supervisor's approval before proceeding, and always use a non-conductive fish tape made of nylon or fiberglass. Planning the installation. The importance of planning any wire pulling installation cannot be overstressed. Proper planning will make the work go easier and save labor. Large sizes of conductors are usually shipped on reels, involving considerable weight and bulk. Consequently, setting up these reels for the pull, measuring the cable lengths, and similar preliminary steps will often involve a relatively large amount of the total cable installation time. Therefore, consideration must be given to reel setup space, proper equipment, and moving the cable reels into place. Whenever possible, the conductor should be pulled directly from the shipping reels. This can usually be done through proper coordination of the order with the job requirements. So we'll set it up on reel jacks. So here are reel jacks with an axle, and you can set these large spools, these cable spools up on the reel jacks, and then pull them in. And here they even have something to aid them. Um, this is electric, and you can vary the speed, and it'll pull the wires off the reels. This used to be done manually. As an extra precaution against error in calculating the lengths of the conductors involved, it's a good idea to measure all runs with a fish tape before starting the cable pull. Add additional footage to the measurements to account for the length required to reach terminations. You'll also need to discard the cable connected to the pulling sleeve or wrap, as it will have been excessively stressed during the pull. Check the final totals against the totals indicated on the wire reels. When pulling conductors directly, do your best to minimize waste. Avoid taking a final length of cable from the reel that's too short for the run. The basic procedure for a wire pulling operation is shown in Figure 4. Job specifications and the timing of other work, of course, can affect the process. I'm not going to go over all these steps. I'm just going to say step 1 is wire pulling preparation. Step 2 is equipment setup. Step 3 is cable setup. Step 4 is the installation. Step 5 is thoroughness. Basic steps for wire pulling operation, interactive. The proper use of appropriate equipment is critical to a successful cable installation. The equipment needed for most installations is shown in the checklist in Figure 5. Some projects may require all of these items, while others may require only some of them. Each cable pulling project must be planned on an individual basis and analyzed accordingly. Measuring tape. A waterproof polyester tape with permanent markings is available on reels for use in measuring conduit and raceway runs. It can be fished through the run manually or with a power fishing system. They always say to add a foot for every 90 and then add the terminating length at the end, probably 5 feet at both ends, like I say, plus a foot for every 90. And these are marked every foot with a sequential number. So you have a start number and an end number, and by subtracting the smaller from the larger, you can see how long the cable pull is. Uh, 1.2.0, pulling setup and locations. This is my opinion. It's not code, it's not the rule, it's not the law. I say don't ever set the reels up on the top of a building and pull down. When you're pulling wire down from a high building, let's say it's 15 stories high, the weight involved in the cable, as the cable gets pulled into the conduit, that weight is additive and it gets heavier and heavier and heavier. It gets to a point where the workers cannot hold back on the cables and they'll run away from you. They'll literally pull all of the wire off the reels and it'll spool down to the bottom floor and stack up in a big stack. It's better to set your reels up on the bottom floor and put the tugger up on the roof or up the penthouse, wherever it is, and pull up. Also, you need a braking system in place. If you are pulling and you need to take a break, put wedges or chocks in the conduit. They make special shaped round wedges that fit in the conduit. You can order them for the size, the proper size, and you can put them around the conductors and push them into the pipe, and it'll keep those conductors, it'll hold the weight of them. It won't allow them to run away. It says each job will have to be judged separately as to the best location for pulling setups. The number of setups should be minimized and the planning to take advantage of the best pull location. The pulling location for a particular job is determined by the cable weight, the pull height, practicality of moving the equipment to the pulling location, number of setups required, and the location of any bends. Also, a separate setup might have to be made at the top of each rise, whereas a single setup might be made at the ground floor pull box location from which several feeders are served with the same size and number of conductors. The weight of larger conductors is frequently the most important consideration when locating equipment. When pulling wire up, the wire weight is working against you. However, If you place the wire at the top of the pool and so that the weight works for you, enough braking must be available to stop the pool when necessary. So here's a highlight. It says it's simple operation for a few workers to roll cable reels from a loading platform to a first floor setup, whereas moving them to upper floors involves more handling and usually requires a crane or a hoist. For reels up to 20 inches wide by 40 inches in diameter, a cable reel transporter or cart can be used to move the cable reels as shown in figure 6. It also acts as a dispenser during the pulling operation. When practical, a forklift is ideal for lifting and transporting large cable reels. Make sure that the wood reel itself is sitting on the forks and not the wire. There are ways to do it and ways not to do it. So here, figure 7, this is highlighted. Proper and improper ways to transporting cable reels. There you go. Having the wooden reel itself resting on the forks of the forklift is okay. Putting it so that this can slide and damage the cable, no, don't do that. Don't stack them on top of each other. Don't put it so that it's lying on the cable and rolling back and forth. Don't allow it to fall off the back of a flatbed truck. Use a lift gate, make sure that it's secured. If you're transporting it with a crane, put a piece of pipe through it and make sure that the chokers cannot move, they cannot fall off. Maybe even put some fittings on the end of the conduit to minimize the chance of that happening. Figure 8 shows an adjustable reel stand with a set of jacks. A set of jacks and a spindle are required for each reel. The jacks shown in the figure are quickly adjusted using any cordless drill. So here's a reel jack that you can use a cordless drill in order to raise or lower this spool. And this is convenient because they've actually pulled all 3 conductors and the neutral onto the same reel. This is something new that they're doing now. Instead of bringing out 4 reels, 3 with ungrounded conductors, 1 with a neutral conductor, they'll bring out 1 reel that has all 4 conductors on that same reel. And it's hard to see this, but it's actually brown, orange, yellow, and gray. So that's the 2 ungrounded conductors, the brown and orange. The 3, brown, orange, yellow, and then the neutral is the gray. You'd also want to pull in a ground with that. Preparing raceways. Another preliminary step before pulling conductors in a raceway system is to inspect the raceway itself. Few things are more frustrating than pulling 4 1000 kc mil conductors through a lube spreader and finding out that the conduit is blocked or damaged. Such a situation usually requires pulling the conductors back out, repairing the fault, and starting all over again. So they have these mandrels that you can pull in. This is a go, no-go mandrel. They say that you just pull it through one time, and if it fits through the conduit, then everything's good, and you can go and do your cable pull. Most of the time, you clean it out with a wire brush or with a flexible mandrel. You take that and pull it through the conduit a couple of times, and it can get any trash, any debris. This is concrete sediment. You can scrape all of that out of there and clean that raceway so that you're ready to go. You're ready to do your cable pull. Figure 10 shows several devices used to inspect raceway systems and prepare raceways for easier and safer conductor pulls. The lube spreader swab in Figure 10 may be used to ahead of the conductors during a pull. Its main purpose is to swab out debris from the raceway and to spread a uniform film of pulling compound inside the conduit for easier pulling. So you might take a couple handfuls of lube and throw it down the conduit and then pull this lube spreader through there, and it'll spread a nice coating of it throughout the pipe. During the cable pull, the entire length of the conductors, you'll lube, especially large conductors, you'll have somebody lubing them. The conduit brush helps clean and polish the interior of the conduit before pulling the cable. Such brushes remove sand and other light obstructions. Note that this brush has a pulling eye on one end and a twisted eye on the opposite end, enabling it to be pushed or pulled through the conduit. One final step before starting the pull is to measure the length of the raceway including all turns and junction boxes and similar equipment. Fish tape or measuring tape may be pushed through the raceway system, and once all the way through, a piece of tape is placed to mark the end. When it's pulled back out, a tape measure can be used to measure the exact length. An easier way, however, is to use a power fishing system to push or pull a measuring tape through the conduit system. Details of this operation are explained later in section 1.4.0. So, it says here, large conductors are especially difficult to bend. With proper planning, you can simplify the feeding of these conductors from one conduit to another. For example, if a conduit run makes a right angle bend through a pool box, the conduit for a given feeder should come into the box at the lower left-hand corner and leave diagonally opposite at the upper right-hand corner, as shown in figure 11. This gives the conductors the greatest possible sweep within the box, eliminating sharp bends and consequent damage to the conductor insulation. Installing pull lines. Wire pulling ropes have come a long way from the hemp ropes used by electricians a couple decades ago. The most common wire pulling ropes on the market include the following: nylon, polypropylene, multiplex polyester, and double braided polyester composites. The type of rope selected will depend mainly on the pulling load, meaning the weight of the cable, the length of the pull, and the total resistance of the pull. Good pulling ropes are lightweight, have little or no tendency to stretch, and have a low coefficient of friction. Ropes are available in various diameters, typically up to about 3/4 of an inch, and in lengths of up to 1,200 feet. It says care must be used in selecting the proper rope for the pull, and then every precaution must be taken to ensure that the cable pulling force does not exceed the rope capacity. There are several reasons for this. The main one is safety. For example, a typical nylon rope can stretch 40 feet before breaking, releasing 200,000 foot-pounds of energy in the process. Think of the damage this amount of energy could do to a raceway system and nearby workers if the rope breaks. Pull lines can be manually fished with a steel fish tape, but much time can be saved by using a blower vacuum fish tape system. In this type of system, a reusable conduit piston, often referred to as a mouse or missile, is blown with air pressure or vacuumed through the run. The foam piston is sized to the conduit and has a loop on both ends. You tie a fishing string to it. In most cases, fish line, the measuring tape is attached to the piston and it's blown or vacuumed through the conduit run. The measuring tape serves two purposes. It provides an accurate measurement of the conduit run and is used to pull the cable pulling rope into the conduit run. In some cases, if the run is suitable, the pulling rope is attached directly to the piston and vacuumed into the run. So here's a vacuum system. You've got a vacuum cleaner. You can use this to actually blow. The string goes right through it, and you can put it in the other opening of the vacuum cleaner, and it'll actually blow the air through the line. This little foam mouse will be pushed through the conduit, and it'll drag the string with it. And if that's not the case, you can tie the string onto it and put it at the opposite end and use vacuum and suck it all the way through the line. So it's a good system. So here they are using vacuum cleaner to pull this mouse with the string on it, pull it into the conduit. Here they're doing just the opposite. They're using the blow mode on this vacuum cleaner. They're actually blowing the air through and allowing the string to go from one end to the other through the conduit. Here's a series of mice, or pistons as they call them, for various sizes of conduit. You have one piston for one size conduit. That's the one you use in that conduit. Don't try to use a 3/4 mouse in a 1/2-inch conduit. It'll get stuck. Don't try to use a 1/2-inch mouse in a 3/4-inch conduit. The air will blow by it and it will not go through the pipe. So you use the proper size mouse for the size of conduit. There are precautions that should be taken when using a power fish tape system. Read and understand all instructions and warnings before using the tool. Never fish in runs that might contain live power. Be prepared for unexpected. Make sure your footing and body position are such that you will not lose your balance in any unexpected event. Use the blower vacuum system only for specific light fishing and exploring the raceway system. Uh, Never use pliers or other devices that are not designed to pull fish tape. They can kink or nick the tape, creating a weak spot. All right. He's up in a drop ceiling. He's using this fiberglass pole for the fishing system. Preparing cable ends. The pull or line or rope must be attached to the cable or conductors so that it cannot separate from the cable during the pull. Common methods include direct connection with the cable conductors themselves and connection using pulling grips or baskets placed over the cable or group of conductors. Now, using the proper type of grip or basket will facilitate the pull, especially on long pulls. Here's a highlight. Workers prefer to use a 3 or 4 hole cable grip with set screws that secure each conductor. So here's a cable grip. It has 4 holes for the conductors for the cables to go in, and then hex keys to tighten down on it so you don't lose it. Here is a swivel rope clevis. So a lot of times when you're pulling around 90s, the rope will get twists in it. This allows those twists to come out of the rope so it doesn't hinder the pull. It's on a swivel. It swivels. There's a basket type of grip that goes on the outside of the cable. Basket grips are easy to use and quick to connect, especially for smaller wires. Here's a highlight. It says, note that the no lube insulation on certain cables requires the wires to be stripped and the basket applied to the conductors rather than the insulation, because that no lube insulation is very slick and the basket may pull off. You need to take that insulation off and put the basket directly on the copper conductors themselves. Most pulling blocks have a rope clevis and an integral part of the block. However, when using pulling grips or baskets in 2-inch or larger conduit, a rope clevis is normally used to connect the pulling rope to the wire grip. 2 types are currently used, the straight clevis and the swivel clevis. You want to use a swivel. It allows the, like I said, the twists in the rope, it allows them to come out. Let's see here. It says generally at a minimum, the ends of the conduit should be first trimmed. Cable cutters that can cut through 1,000 kc mill conductors save workers time compared to using a hacksaw. There are also cable strippers adjustable from 1/0 through 1,000 kc mill that handle mid-span and termination stripping of THHN, THWN, XHHW, and similar insulations. These tools are excellent for stripping conductors used in set screw clam type pulling grips. To use a stripping tool, first mark the required distance from the end of the conductor using the pulling grip as a gauge. Close the jaws of the stripping tool on the cable and twist. These self-feeding devices ensure positive progression down the cable to any position desired. To stop stripping, apply back pressure to the stripper until a full circle has been completed. All right. And the following should also be observed when working with cable terminators. Wear eye protection. Inspect tools before using and replace damaged, missing, or worn parts. Be prepared for the unexpected. Make sure your footing and body position are such that you will not lose your balance. The material should match the stated capacity and type and size. Do not use the tool on or near live circuits. Grips and swivels. So here, basket grip. Here's one of those set screw grips. Here are some swivel clevises. Selecting cable pulling equipment. This is talking about a rope cable puller. Generally, cable reels are placed at one end of the raceway system, and the cable puller is set up at the opposite end. One end of the previously installed pulling rope is attached to the clevis, basket, or other cable grip to which the conductors are attached. This is a highlight. The other end of the rope at the cable puller is wrapped around the rotating capstan, the drum on the cable puller. So here's the capstan. This is a drum. And you take the rope, the pulling rope, and you go around like 5 wraps. And then this worker can use 20 pounds of force to put 17 pounds of force on the pulling rope. So be sure to check the pulling rope rating. Many pulling ropes are available today, are made of synthetic materials designed for pulling by hand or with a winch type puller. However, if you're using certain synthetic ropes or friction type capstan power pullers, make sure the rope is rated by the manufacturer for this use. Here's another highlight. It says check the cable manufacturer's recommendations and contact the lubricant manufacturer about the compatibility of lubricants with specific cables. That way there's no contamination of the insulation. The appropriate wire pulling lubricant, often referred to as soap, is inserted into the empty conduit as well as wiped thoroughly onto the front of the cable. One or more operators are on hand to feed the cable, while one worker is usually all that is required on the pulling end. Number of wraps on the capstan decides the amount of force that can be applied to the pull. The operator need to apply only 10 pounds of force to the pulling rope in all cases. With this amount of force applied, 1 wrap around the rotating drum, 21 pounds of pulling force will be applied to the pulling rope. 2 wraps can provide 48, and 3 wraps can provide 106. More wraps provide more pulling power. So in this chart, 5 wraps makes 512 pounds of pulling force when the operator applies 10 pounds of force to the pulling rope. Caution, here's a highlight. Be certain that all communications equipment is in working order before the pull. If you're using radios, make sure that all the radios are turned on and are at the same channel and everyone can communicate. Place personnel at strategic points with operable communications equipment to stop and start the pull as the conditions warrant. Here's another highlight. Anyone involved with the pull has the authority to stop the pull at the first sign of danger to personnel or equipment. Use compatible equipment. Always be prepared for the unexpected. Inspect your tools, rope, and accessories before using. Personally inspect the cable pulling setup, rope, and accessories before beginning the cable pull. Make sure all electrical connections are properly grounded and adequate for the load. Use cable pulling equipment only in uncluttered areas, and remind all workers that anyone can stop the pull if it seems unsafe. Types of cable pullers. Power cable pullers are available in various sizes and capacities. They range from lightweight units that can be set up and used by a single person to heavy-duty units for high-force cable pulling. Figure 17 shows an example. The 1,000-pound puller shown in Figure 17A is driven using a cordless power tool, while all the other pullers shown require a 120-volt AC power source. So here are some that you can crank by hand. This one you can use a stroh motor. Here's a 2,000-pound puller. You have to plug it in. And here's 6,000 and 10,000 pound. And that's the capstan where we're talking about. That's the drum that you wrap the rope on. Puller set up for a downward pull. So here they're coming from above. They're coming into this conduit, and they have these pulleys set up so that the tugger can pull that rope straight out of the conduit rather than at an angle. And this one, they're doing the same thing, only with a vertical pull coming up from the bottom. So it comes around these rollers, and it's pulling out straight rather than pulling it at a right angle. You don't want to do that. You don't want to pull at a right angle. Cable pulling instruments. So there are cable length meters. This meter is available for direct reading in lengths up to 20,000 feet or more. Determine the length of a conductor on a roll. Select the wire size and material, such as copper or aluminum. Then connect the leads to each end of the wire and read it to display. So basically, they're taking an ohmic reading of the cable on this spool, and you can dial in what size copper or aluminum conductor, and it does the math for you. You can do the same thing using the code book and turning to Chapter 9, Table 8. You can find out what the resistance per 1,000 feet is for each separate cable. And then you can take an ohmic reading of it if you have a very accurate ohm meter, and you can do the math and find out how long that cable is. Circuit tester or wire sorter. This instrument is used to trace conductors on energized circuit, or de-energized circuit, excuse me. One lead of the transmitter is attached to ground while the other lead is attached to the wire being traced. The receiver is then taken to the opposite end of the conduit where it will capture the signal on the traced conductor. That wire is then marked. Other wires are traced in the same manner. So it's a wire tracing system. A dynamometer. This meter measures the pulling force during a cable pull. Many are designed to mount on a specific cable pulling tool and are shipped as an integral part or optional part of the cable puller. I'll tell you, basically, it's an ammeter, and that tugger is going to have a certain amount of amperage flowing through it when it's in a no load situation. And as you start putting load on it, it's going to use more and more current. The current's going to go up because the motor's under stress. And they just adapt it to read as foot-pounds of pressure, pounds of pulling force rather than amperage, but it's a dynamometer. Here are lubricants, guiding and lubricating conductors. When guiding conductors into a conduit raceway during a pull, the conductors may tend to twist, overlap, or become crossed during the pulling operation, especially if fed from boxes instead of reels. Excessive twisting, overlaps, or crossovers can cause binding of the conductors around turns, create obstructions, and damage the insulation. Operators at the feeding end of the pool must attempt to keep the conductors as straight as possible. I'm going to make that a highlight. You have to make sure that the conductors do not cross each other. Lubricants should be applied generously during the pull to allow the conductors to slide easily through and over each other. But make sure that you keep those wires straight before they go into the conduit. You don't want them crossing. And here's section 1 review. When ordering cable for an installation, it's best to, and I'll let you look that up. A 60-inch wire reel is best moved using. Test mandrels should be sized at, I don't think we're going to know that, I think it's 80% of the conduit size. A conduit piston must be, and I'm going to let you look that up. Long pulls of large conductors will most likely require the use of, and last question here, 3 wraps on a capstan will provide how many pounds? You can look that up in that chart that we were looking at. All right, we'll go on to section 2.